This is a recorded explanation of the solutions for exercises 35 and 36 in Chapter 5. Both of these solutions make use of Bayes' theorem. In exercise 35, and with anything relating to Bayes' theorem, the key really is to identify the various probabilities and the conditional requirements of the problem. So in the first example, so in problem 35, we can identify prior probabilities as, so the probability A1 is the probability of having a night game, and A2 is the probability of having a day game. All right, so once those two probabilities are noted, the next step would be to recognize the fact that we have some conditional probabilities associated, and we're going to assign B to indicate or to represent a win. Okay, so in our conditional probabilities, these are the first one is the probability of a win given a night game, and the second one is the probability of a win given a day game. All right, and once we've assigned those probabilities, we can plug them then into the formula, and it's a matter then of doing the math. So in this first example, we're going to take the probability of A1, the probability of a night game, times the conditional probability of B given A1. Right? And then we're going to divide that by the probability of a night game times probability of winning a night game, plus the probability of a day game times the probability of winning a day game. All right, and you can see the result there. The next example is exercise E36, and that's pretty similar. Okay, again, the keys to this one is to identify the probabilities, recognize the prior probabilities, and then the conditional probabilities. And in this case, the probability that a student will complete the assigned problems is 80%. The probability the student will not complete the assigned problems is 20%. All right. If we assign B to represent the probability of passing the course, then we can identify our conditional probabilities as the first one is the probability of passing the course for a student that has completed all the assigned problems, that's 90%, versus the probability of passing the course for students that do not complete the assigned problems, which is 60%. And again, we would plug in those probabilities into the formula, and we see that it works out to 85%, 85.7% roughly. So, okay, this has been an explanation of problems exercises 35 and 36 in Chapter 5.